Today we're going to be talking about basic compound interest. So this is one of my favorite units in the class because we'll be talking a lot about how money works and how it works with mathematics. So the first thing to note is going to be a formula we'll be using. So you're going to write this down. A is equal to P times 1 plus R over N to the power of NT. So it looks really crazy, but don't worry, we're going to break this down. This A is going to be your final amount. This P, this is going to be your initial amount, or in money world, we call this the principal. The 1 is, that's just a 1. The R right here, that's your rate. N is kind of weird. N is going to be the amount of times you compound. So compounded N times per year, because in money we typically talk about things in the time frame of years, and that's why T is obviously going to be time. And again, for most of these problems, everything is in years, and that's true of life as well. You ever see commercials with like interest rates? That's always going to be typically the yearly rate. Okay, so let's practice using this formula right now. It says a credit union pays interest of 8% per annum, so that's like per year, compounded quarterly, so let's highlight 8%. This is important, every year, compounded quarterly. If $1,000 is deposited, okay, that's your initial, and the interest is left to accumulate, how much is in the account after 1 year? All right, so let's try to use that formula. So A, we're looking for the final. We put in $1,000 into the account. 1 plus, the rate is 8%, so convert that to a decimal, 0.08. Compounded quarterly, so that's going to be every quarter, meaning 4. And carry the 4 up top. And this is 1 year. And then we got to calculate that. So now we're going to grab our calculator and type it in. 1,000 multiplied by 1 plus 0.08 divided by 4 to the power of 4 times 1. And there we go. We're going to round to the nearest cent, so $1,082.43. Okay, now you might be wondering, like, what's the point of this 1? So I'm going to show you by taking it out. So let's say we take this formula, and let's just get rid of the 1. Let's see what it does. Take a look at that. So notice how the whole thing kind of breaks down. Like nothing really happens. Like look at that number. That number is not very helpful at all. So the reason you need that 1 is because it's accounting for the money you're actually putting in. So that's why this thing is extremely important. Because if you forget that, everything's going to be wrong. This is going to make sure that it basically keeps your initial amount in the formula. Because without that, you basically lose the money you're putting in the calculation. Okay, let's try this. Investing $1,000 at an annual rate of 10%. Okay, so annual rate 10%. And then it says compounded annually, semi-annually, quarterly, monthly, daily. Okay, so this is a multifaceted problem. It wants us to do a whole bunch of things and take a look at what's happening. So let's first start with compounded annually. And let's see what happens. So A would equal 1,000 times 1 plus 0.10 over 1, and then 1, 1. So 1,000 is our initial. 1's going to make sure we don't lose our $1,000 here. And then this 0.1, that's our rate, 10%. And there's a 1 here because it's saying compound annually. So that's going to mean is that the interest rate only happens once a year. So if you have your money, it's going to pay out exactly one time. So 10% over 1, and that 1 is again going to copy that over. That's going to make sure you get your money one time, and then for 1 year. So we're going to come back here and type it in. 1,000 times 1 plus 0.10 over 1 to the power of 1 times 1. Okay, $1,100, which makes sense, right? Because if you think about it, if you're getting paid 10% interest and you only compound it one time, 10% of 1,000 is $100, so you get $1,100. Okay, now let's go on to semi-annually, and let's see what happens. A is equal to 1,000 times 1 plus 0.10, but semi-annually means you compound the interest twice. So you're going to put a 2 here, and then 2 and 1. So what's going to be weird here is the calculation is very similar, except there's a 2 here, and we're going to see how that actually does affect what happens. So go to your calculator, and we're going to plug in 2's here now. 2, 2, and look at that. It's a little more money. $1,102.50. Meaning, if you compound semi-annually, you get $2 more about, which is pretty good, right? Because the interest rate is the same. So now let's do quarterly. $1,001 plus 0.10 over 4 to the 4 times 1. Okay, let's go back to our calculator. Double tap your screen. Change the 2's to a 4. And look at that, you got more money. You got to $3.81. So this is $1,103.81. So you're noticing the more we compound it, we're getting more money. That's really weird, really interesting. So let's see what happens. We're going to skip monthly. You get the idea. Let's go to daily. So daily would mean every single day they're going to pay out your interest. So they're going to take that 10%, they divide it by 365 every day, and they're going to do it 365 times, right? Because that's how many days there are in a year. And let's actually see how much more money you get. 365, 365, and take a look at that. You got to $5. So this is $1,105, and is that 16 cents? Yep, 16 cents. So take a look at this. Annually it was 1,100, and every time we increase the amount of times we're compounding, you got more money, even though the interest rate never changed. So the next logical question would be, does this go on forever? Like, what if you could compound it more than daily? So we're going to do a little experiment here. Let's say we're going to invest $1. So our initial is $1. And to make it simple, let's say we have an interest rate of 100%. So a really good interest rate. Let's see what happens. So we're going to do 1 times 1 plus 1, right? Because the interest rate is 100%. And we're going to compound it a lot. Like, let's do like 1,000,000. And let's compound it for a year. And let's really see what happens. So let's go to our calculator. I'm going to get rid of all this stuff. So 1 times 1 plus 1 over 1,000,000. And that's to the 1,000,000 power. And that's going to be times 1. Let's see. Oh, that's interesting. It says 2.71828. That's really weird. So notice how this became 2.71828. What happens if I make it 10 million? Look at that, 2.718281. Okay, let's add another 0. 2.7182818. Oh my gosh, do you guys see what's happening? 2.718281828. It's approaching E. That is wild. So E is actually coming up in interest rates, meaning if you theoretically compound it an infinite amount of times, like as many times as you could, you actually approach E. So that is crazy. So E kind of comes up there. So what this is called is continuous compounding. And for continuous compounding, that's exactly the situation we're describing, is that when something compounds basically nonstop. And the formula for that is P times E to the RT, or PERT. So this is a really nice formula. And again, that's your continuous formula. So to use this, it's the exact same way. A is equal to 1,000, and then E to the power of 0.10, and our time frame is 1 year. Let's grab our calculator. Let's calculate. So 1,000. That's important. You have to put times here, otherwise the calculator will freak out. Then shift natural log to get E, and then 0.1 times 1. And there it is. That's our amount. $1,105.17. That's how much money you'll get compounded continuously for 1 year. Now, why that's powerful is because some people might believe this indicates you keep getting money infinitely, right? Like the more you compound it, you keep getting more and more money. What we just proved is that that's not true. It stops at E, which is crazy because that's the number we're talking about. This is Euler's number. So that's what this formula is saying, is that if you compound something continuously, it doesn't just keep growing forever. It hits a point where it doesn't grow anymore. It hits E, and that's why that E is there. Okay, now the last example is going to be kind of like an SAT kind of problem. So this is an SAT example. The SAT doesn't use the basic compound interest formula right here. It uses an even simpler formula. The SAT uses this right here. Y equals A times 1 plus or minus a percent to the T. So that's your SAT version. And notice how it's way more simple than what we're doing. So A is your initial, this is your rate, and then right there is your time. And then this is clearly 1, and plus or minus to indicate increase or decrease. So let's try it here. A new car is estimated to depreciate at 15% a year. So depreciate means it goes down in value. If you're to buy a new car that costs $40,000, write a function that would model that car's value after t years. Okay, so value, that's V, we're calculating the car's value, so that's why we're going to put that here, is equal to the initial, which is $40,000. And then we're going to multiply that by 1, and it's depreciate, meaning it's going to go down, so minus 0.15. And then it's after t years, which means you get 40,000 times 0.85 to the t. And this is going to model the function. And this is actually true. You can look it up. A car actually does depreciate at around this rate. And let's actually calculate that. Let's actually add an extension. What is the car's value after 10 years? Let's see. So 40,000 times 0.85 to the 10th power. So that's 7875 about. So notice how this is crazy. The car you bought for $40,000 after 10 years is only worth about $8,000. That is crazy considering you spent $40,000 on it. So that's what a lot of people don't understand about math, is that this kind of stuff happens to you. So if you buy a new car, you have to be aware of what happens to your money. It goes down drastically, because look at that. So that's why, in general, I always tell my students, when you're just starting off after college, please don't buy a new car. That's a really bad thing to do with your money. Okay, so good luck on the questions, and I will see you in class.